All right, let's see if we can walk through what we know so far with a new example. So suppose, hypothetically speaking, that I want to start a new line of cookies, and I'm going to have them be low calorie. So my claim is that Abel's hypothetical cookies average less than 200 calories. So let's start by translating that claim into math. Average has a different symbol. The last claim in the last video was about a proportion. This is about a mean. So this symbol for a population mean looks like this. It's a Greek lowercase mu, which is like an m. But anyway, the average is less than 200. That's going to be one of our claims. We know we need the opposite, the logical opposite of that. And we set these two up. You always use the same symbol, the same number, and just say if it's not less than, what is it? Like, well, if it's not less than, it's got to be greater than or equal to. So not just greater than. All right, keep in mind that you need to cover all possibilities, including that it might be equal to 200. So notice we've got a less than and we've got a greater than or equal to. And if you remember from the last video, one of these is going to be the null, one of these is going to be the alternative, and the one that is the null is always the one that has the equal sign in it. In this case, it's a greater than or equal to. But that's the one that has the equal sign, along with the greater than, but the equal sign is here. So this one gets to be the null. Notice that this time around, the null is not the original claim. So the null has nothing to do with what the original claim is. The null has everything to do with the equal sign. So the null has the equal sign. The alternative does not have the equal sign in it. So this would be then the point where, well, I guess we could even draw the curve right now. So we sort of draw the curve based on the null. The null says it's greater than or equal to 200. Of course, you can't draw a curve centered on greater than or equal to, which is why you always focus on the equals to when you're actually drawing the curve. So you say for the null hypothesis, this is one version of the null hypothesis, is that the mean is equal to 200. And it might be greater than 200 also. But we will reject that null only if we see something way down here that's substantially less than 200. So this is the point where you go take a sample. You get a bunch of Abel's hypothetical cookies, you put them in a bomb calorimeter, and you determine exactly how many calories are in each one, and you get a sample mean. And the sample mean, I'm just making this up now, but the sample mean comes out 183.6. And again, I don't have the context here. I don't know exactly how wide this curve is, but in the next section, a couple sections away actually, we'll be able to figure out exactly where that is on the curve. So there's sort of two possibilities here. One is that 183.6 is there on the curve. And in that case, you'd say, yeah, that's actually pretty common. If the mean is 200, if the null is true, this doesn't prove anything to the contrary. It doesn't prove the null is lying. So that's one possibility. The other possibility is that when you crunch the numbers, you find out that 183.6 is down here. And then you're like, if the mean is 200, then 183.6 basically should never happen, or its probability would be incredibly tiny. Right? This is the sort of case where we would reject the null. The way we're going to figure out where that 183.6 is So maybe I should just put this right here. So if the 183.6 turns out to be more here in the typical spread for a 200 average, then we won't reject the null. The book is going to use the phrase fail to reject the null, but you can also say don't reject the null. Notice what we're not saying here, by the way, is we're not saying accept the null or the null has been proven or the null is true. We're never going to say that. Because does 183.6 prove that the null is 200? No. I mean, it doesn't necessarily mean it's 200. It's just part of the normal span if the mean was 200. But 183.6 could be evidence that the average is really 185 or 182 or 183.6 might be the real average. Here's the tricky bit, I guess. We can reject the null. Absolutely. All right, this case over here. If what we see is just crazy off the edge of the curve, we'll say, I don't think this is the right curve. I don't think it's averaging 200. Even low-end samples would be higher than this. So we can reject the null and say, I don't think the null's right. We cannot ever accept the null. Right? If 183.6 turns out to be over here, that doesn't prove the null is true. Even if we get a sample that's right on 200, maybe that sample was a little bit higher than the real value or a little bit lower than the real value. It doesn't tell us what the average is actually equal to. So we will never accept a null that says it's equal to something. But we will either reject the null or we will say I can't reject the null or I fail to reject the null. So the way we figure out where this 183.6 is, here or here, it turns out we're not actually going to graph the curve every time. We could do that, but we have a more efficient way of figuring this out. And we're just going to say, to answer this question, do we reject the null? We are going to find the probability of our sample. We're going to find out where it sits on the curve. By figuring out probability. So we're going to compute the probability of our sample with this curve. In other words, if the null is true. When we compute that, we'll refer to that as a p-value. And again, we're not really getting into crunching those numbers until the next section. But let me just say right now that if 183.6 does turn out to be here, the p-value, the probability of that happening based on this blue curve is probably pretty good. It's probably like 30% or 40% of the time we'll get a sample that's like this. So I'll just make up a number here. Let's say 0.372. I'm going to say, okay, that's not unusual. And it's not less than 5%. Certainly is not unusual if the mean is 200 to see a 183.6. Okay. On the other hand, if it turns out that 183.6 lives over here on the curve, this thing probably has a p-value like 0.0003558. In other words, you'd say if the average is 200, really, then getting a 183.6, extremely unlikely. And that's the point where you say, I am going to reject the null. This incredibly unlikely thing happens. Seems more likely that 200 is not the right number. Okay, so that's a little bit more of the computations. In the next video, we're going to take a look at a few examples from the homework so you know what you'll really have to be doing to walk through the homework. And then you'll be ready to actually tackle the homework. So see you in the next video.